Okay.
Me too.
Okay, thank you for reminding me. Okay. So that description where we assume, okay, the propagation of light as the ray of light and represent that by drawing the line with the arrows, that's the geometric optics. Okay. So now we are back to the description in terms of wave and motion in terms of wavefront. So just like when you put something, let's say if you tap on the water surface, what happens? You generate a wave and the ripples are the wave fronts, right? So they move in that form. So you can see that those thingy a little bit here and there. So why we are coming back to the wave description? Why just the description of light in terms of, let's say, ray and geometric description is not enough? So what happens is those rays of light, they go a straight line when you have the openings larger than the wavelength of the light. But when the openings becomes very small and light is trying to pass through that, what happens? In that case, rather than going in a straight line, it can bend. And remember, I'm not talking about bending phenomenon when it goes from one medium to another medium. I'm not talking about that. That is the refraction we already talked about, and we just use the ray diagrams to describe that. Okay. But what happens is, yes, light travels in a straight line, but when it has to pass through a very small door, how small is small? When the opening of the door becomes about the size of the wavelength of the light, in that case, what happens is, even when it is just passing through the air, through that opening, small opening, it can bend. Okay. So that phenomenon is called a diffraction, and we cannot describe that by using the the ray optics or geometric optics. So there are these phenomena. For example, we see this color soap and color thin film sometimes when there is little oil on the surface on top of water. And then you may see from the top and you may see this color film, right? Similarly, this soap bubbles may look colorful. So to describe that phenomenon, and similarly to describe this spreading of the wave. So see, the water is just going through the one medium here through this small opening. So this opening is small for the water wave. So what happens? Rather than just flowing straight, it kind of spreads. So you can see the waves are spreading like this. So same thing happens to the light rays as well when the opening becomes smaller. So that phenomenon we call diffraction. So to describe that, we need to talk in terms of wave, okay? And this is called physical optics. The ray description, that's called geometric optics. And this is called physical optics. Okay. Oh, it's right there. Okay, and I think I already spent time talking about this. So what happens is This phenomenon, interference and diffraction, occurs when one wave meets with another wave. So what happens after mixing? What happens? What's the result of interference and diffraction? To know that, to explain that, we need to know what are the possible ways two waves can combine, okay? So the superposition is just fancy name for adding two waves, okay? So for example, we have one wave here, another wave here, okay? So now let's suppose we are mixing these two waves together. So the resulting wave is this. So depending on how, what position they are, how they are lined up with each other, what we're gonna see is this changes, okay? This thing changes, this thing change. So let's take a look here. You see here, the combination of this and that, and in this case, this crest of this wave and the crest of another wave, they are lining up in the same direction. What's the result? Both of them are reinforcing each other, means total gonna be larger. Okay. Now, let's see what happens when they move a bit further. So now they are not quite lined up. So the maximum is here, but over here is just this much. But for this, this is that much. So what's the result here at this point here? So that is the result of sum of this and that. So when they are in same direction, it gets added. But if one is in opposite direction to the other one, what happens? It gets subtracted. So for example, near this point, for example, here the result is 0. And why is that happening? Let's take a look. Looks like I'm not drawing it correctly. Something like this. So in that case, what happens is, so middle is there, let's say, and middle is there. Looks like both of them have almost 0 values there. So in another diagram, I'll show you where we measure from. So if it is going up and down, we measure up and down. That's what we call amplitude from the middle point, okay? Some reference point, and that's the reference line I'm trying to draw here. So what you want to pay attention is that this thing is, this peak here is sometimes larger, sometimes smaller, getting smaller, and it goes to the other side. So it's going, fluctuating up and down. So that's what's happening when these waves are combining with each other in this animation. You see that? So it's now in the opposite direction. So this is how we describe it. So this is when peak and peak lines up, then the result is sum of the peaks, and those peaks are called amplitude of the wave, right? So that's there. So that's the amplitude, and this is also amplitude, but if this is positive A, then this is negative A. So if it's down, it's negative. If it's up, it's positive. But you can reverse positive and negative if you like. Down positive, up negative, it's fine. You can do it. But if one side is positive, another side has to be negative. And that's the thing you want to keep in mind while dealing with this kind of situation, right? And so if I had something like this, let's say 1 going something like this, A1 going something like this, and A2 going something like this, let's say, then this would be A1 and this would be A2, but this A2 would be, let's say, some negative number, -1, and this would be positive, let's say 2. A1 is +2. So what we can do is we can just find the resultant, this one here at that particular point by just adding these. So A, amplitude of this resulting wave at that point is A1 plus A2, means it's a 2 minus 1, which is just +1. So in this case, what's the result of mixing up this A1, A2, these two waves? So the result is going to be something like this, +1 with the, the amplitude with +1. So that's how we just can add algebraically by taking account of the sign, positive and negative. Okay. So now, two waves are called coherent if or when they move from, let's say, one point to another point, they are, the frequency is remaining same. So, and then they also keep the phase same. So what's the phase of the wave? So right now what I see here, oh, already moved. What I see here is when one is going up, another one is also going up. So two waves, while one is going up, another one is also going up synchronously, okay? When that happens, we call, okay, they are in same page. But for example, when, let's say if this was going up, at the same time this was going down, that means those two are in opposite phase. Now, by the time, it reaches at highest point and it just starting up, then we say, okay, the phase difference between them is like a 90-degree, because remember 90-degree or pi/2 in terms of radian, right? So if we have a wave, something like this, here, that's the maximum value and this is minimum value. So between maximum and minimum, how much is this? This is quarter cycle. One wavelength means like a full cycle. That means if it started from the top, it goes to the other side and comes back to the same level, that becomes full cycle, and that is wavelength of the wave, right? Crest to crest, or could be trough to trough. So it is one full cycle, and wavelength is lambda. Now, when it goes from here to here, from maximum to minimum, that is half cycle. That is equivalent to 180-degree or pi radian. This one being in between maximum on one side versus maximum on the other side. So in between being this 0 point there. So that's a 90-degree, which is equivalent to, or let's say quarter cycle, right? So if we say one oscillation is 360-degree, it's like, think about like going from here to and coming back to the same point. That's 360-degree in a circle, right? So when something oscillates and it starts from here, goes to one side, comes back here, and then goes to other side and back same place, that's one cycle, right? We call that period as well, right? So one period is equivalent to 360-degree, and we can say half period is 180 and quarter period is 90-degree, something like this, right? So when we are saying phase, like how far one, is in terms of another one when they are oscillating. So if they are going something like this, they are in phase. If one is going down, another one is going up like this. If the oscillation is like this, that's out of phase, okay? And there can be in between phases as well. So here when it says maintains the fixed phase relationship, what it means right now they are lined up, and let's say when they, when they travel, let's say moving from here to here point, they are keeping the fixed phase relationship. They are keeping fixed phase relationship. How do I know it? See, this is again lining up with each other, right? So if the frequency is same and if they are keeping fixed phase relationship, then that kind of wave is called a coherent wave. And this, when we describe this interference, what happens when this interference phenomenon occurs only when we have the coherent waves, okay? So that's why we need to first know what coherent wave means, and then we can talk about mixing them, okay? So what happened here? Yes. So now let's suppose we are mixing them. So since, they are always lined up, and when they are lining up with each other, the amplitude gets added, just like we saw. So when the mixing up is happening, like that, that means it's the constructive interference. One is reinforcing another one. So yes, so it has to be coherent waves. And when they are mixing and reinforcing each other and giving maximum amplitude, then that's the constructive one, okay? But if they are going other way around, so in this case, you can see here, they are lining up, right? So when there is constructive interference, these two can be replaced by just one. So one with the larger amplitude, okay? So if, let's say, both of them had, let's say, if A1 is equal to A2, or when A1 is equal to A2, then AC becomes 2 times either A1 or A2, right? So that's what that is. So that's the amplitude of this constructive interference, if they were same. But even if they are not same, then we can use this formula to find the resulting amplitude after the constructive interference, okay? So that's what we see here. So now there is a question for you. And you have a minute to answer this question. Thirty more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Let's see, how did we do here? So both of them have amplitude A, so that means it's like saying A1 is A, A2 is A, So that means when we have constructive, same point in phase means they are lining up in the same direction, right? So that means it's going to give you constructive interference, means A1 plus A2, means you just add them. A plus A is 2 times A. So they get added, right? So that's what this is. Okay. So I'm pretty sure you have watched the, like tsunami wave. When there is tsunami wave, what happens? It can just, pass through homes, trees. It can cross the homes and trees and so on. So why the tsunami is so powerful? It comes with very high amplitude of the wave. Okay. So how much powerful it is, how much energy it has depends on the amplitude. Okay. So intensity, so amplitude, so how powerful it is. If we want to describe that for the light, what we do is we want to see, okay, how bright it is. Even better, how bright a surface gets illuminated. So for example, here, okay, when I'm bringing this closer to the light surface versus farther from the light surface, how intense the brightness gets, okay? So we can talk in terms of intensity. So that intensity depends on the amplitude of the wave. Intensity depends on the amplitude of the wave. And it is square of the amplitude, okay? So now we learn what happens to the amplitude when there is constructive interference. They get added. Then what happens to the intensity then? See, if that was the question, then would be what? New amplitude would be AC square, and AC, I would write just proportional here for now, okay? And this AC being 2 times A, we have to square that. 2 times A means this A I'm talking about. So what happens is intensity becomes 4 times the original A square. So when amplitude is double, intensity becomes 4 times larger. It's a square relationship, okay? So similarly, when you have a water wave, as the height of the wave or the amplitude of the wave increases, what happens? It becomes more powerful. So that concept and intensity, we're gonna pick it up from here in the next class, okay? So since we did not cover much today, they're not gonna be weekly tests, but there may be a little bit more for the pre-lab, not pre-lab, but the pre-lecture exercise, okay, pre-class exercise. And I'll be posting that tomorrow. Okay, I'll see you guys next week. Okay, folks, some of you are still hanging around there. If you have quick question, please feel free to ask. I have another class to go otherwise, okay? or maybe not.